Hello, hello, Tor. Can you hear me?
Yeah, I can hear you loud
Good.
and clear.
Loud and clear. That sounds excellent. Well, we had some trouble the other day at one of the meetings, but
Mhm.
this is good. Fantastic. Well, I want to quickly chat with you because, according to the latest release on the Iceland Met Office, we are dealing with a possible eruption coming in the next little while along the Sundhnúkar chain again, and this would be the ninth one in the sequence of eruptions along that, vent alignment, and. The accumulation seems to continue, but I also understand, although it reached a threshold like similar to previous eruptions, it looks quite quiet on the ground. Let me just share that with you. I was looking at the
I think the
webcam.
next one might be the 10th.
Yes, the 10th, that's right. So yeah, we had nine on the Sundhnúkar chain and the
Mhm.
10th, and we had three on the Fagradalsfjall, so
Yeah,
12 in total. And now we are potentially looking at the 13th in the entire sequence since 2021. So this is just one of the webcams here, and this is from Thorbjörn Mountain. So Grindavik would be here towards the right, and Reykjavik, etc., would be up here.
yeah,
And
just over the hill there.
exactly, and Svartsengi is just about here on that
Mhm.
side, on the other side of the road. But it all looks very quiet. There's a little bit of fumes coming out. There's a little bit of degassing, but it doesn't look particularly threatening, nor do the fumes look very blue or so. It's not. It seems to be a lot of water, I guess. So, and when we look at the
Yeah, but
Icelandic.
the point about this is actually as uh, uh, quiet as it has been for a very long time. So there's actually very little fumes coming out at the moment, and that probably is just the artifact of that the repose period
Mhm.
that we've been dealing with now is the longest in the whole sequence.
That is exactly the point. And I looked at this morning. So this is updated just yesterday, I think, 6th of January. And it says here from the Met Office, magma accumulation continues. And there is, of course, a continued possibility of an eruption. However, earthquakes are pretty low. You could interpret that in different ways, but it means there seems to be not a lot of magma on the move. It could also just mean that the crust is already pretty broken up.
I think
Um,
it's a latter, really. I mean,
it might well be the latter. I was worried about that as well. So,
because what we people have been observing, or we have been observing with these events, is that the seismicity between events and also in relation to onset of events is getting less intense and shorter.
and
So it's almost like you're broken up. Almost everything can break, so there's nothing left to break, so you don't get any earthquakes.
and looking at this diagram they published here, this is effectively a volume of magma accumulation in the upper crust, and this is all the Sundhnúkar eruptions: one, two, three, four, five, six, seven, eight, nine, and that potentially number 10 coming. And they have this gray bar here, which they consider the threshold, at least for the last five or so, in terms of volume of accumulation.
Yeah, basically that great bar is the lower bound for the last five eruptions and the upper bound for the last five eruptions in terms of magma accumulation as they estimated from the inflation.
Hmm.
So
And we're
basically,
now,
this is
we,
calculated using some assumptions based on the amount of inflation. So
and of course, I can see why they have to kind of give a warning, or at least say that there is a high possibility, because we are
yeah,
in that gray threshold bar area of this diagram now. However, I also understand accumulation is not a persistent feature. It's not constant. It's changing. So
yeah,
the
there are issues. Yeah, and something we need to think about in terms of that is, you know, it's not a constant feature, not like anything and any other things in nature. And the assumption there is that if you get above, what is it, 18 million cubic
Yes.
There's a magma accumulation,
Or
then you
17 and a half, but yeah, yeah, around
yeah,
18.
then you're getting into the critical zone. Uh, and then 23 million, that's the upper bound based on past experiences.
Somewhere
And
here,
the
yeah.
average is 21. So if you assume that it needs to at least reach 21 million, then a likely eruption date would be around the 20th of January.
20th of January. Now, I remember we had a previous kind of
No,
guesstimate about.
but if it goes to 23, then it would extend into February.
Yeah,
But that's
absolutely. No, no, no. I'm just saying.
and there is no guarantee that, even if it reaches the average value of 21 or maximum value of 23, that it will erupt. It could continue accumulating. It might even go well beyond that. Who knows? But then things would have changed. At the moment, the rate of accumulation has been steadily going down.
And
And
that's an
and
important point to make. And
yes,
I think that's crucial, actually. So
and it's
we,
below 1 cubic meters per second at the moment. That which is the lowest it's ever been, and it keeps dropping. So it's not reached any kind of a steady state or equilibrium situation at all. It keeps dropping down. So eventually, it will stop. If you get to zero, then nothing is going to
exactly.
happen.
If you get to zero, then I mean the degassing in the shallow level reservoir might still cause a little bit of overpressure with time. But I mean, this is not the kind of thing. This will not yield big eruptions, I would hope.
No, no,
So
but see, so I think we're approaching the end, but the end of this thing seems to be sort of let's put it this way: the decay of the system seems to be exponential.
and this actually makes me think that unless something strange happens, I actually start to feel that the system is calming down because we had discussions about that this could go on for years, decades, potentially even hundreds of years. And of course, this is all a long shot, but I mean, it seems that the Sundnucker system seems to kind of relax now. Maybe there's another eruption,
Yes,
sure, but I think we almost would need to have another a tectonic event and maybe a shift of eruption site before this comes back in a major way, as we've seen in 21 and towards the end of 23, beginning of 24, when Sundnucker started. So, do you
I
share
agree.
that
I think
Yeah.
that I think that's really what's going on, and it's sort of gradually dying out, and new injection or some kind of a shift in the locus of main activity deep down there needs to change before we get something major happening again. I mean, we might have one or two eruptions uh, at best, I think, maybe none.
Yes, I'm actually. It could even be that this. I mean, I'm not against an eruption. I
And
mean,
there's another this
great
year.
scientific opportunity, but it's in a way I can also see that people in Grindavik must be, or Svartsengi power plant
Yeah,
folks must
and
be really
I think
tired
there's
now.
an
So,
additional evidence in that this I've analyzed our samples for the melt composition
hmm
from the last event. All of those that we collected from that last event, it represents the early stages of the eruption, but they're all depleted melts.
okay, I
So
see.
they're depleted, but there's nothing, no enriched
Okay,
composition in those samples that we had and we analyzed. I'm not saying it isn't in the lava flow or somewhere it came up at some stage, but we did not catch it in our sampling.
okay, good. So,
And but taking that on sort of on face value and considering the fact that we've done similar sampling in the past and we always caught both components, it seems like this depleted component, which I think is the old magma, is getting more abundant. So if we've heated up enough of the old magma down there to actually mobilize it and bring it up, and that might also mean that the the new fresh magma, there's less and less of it.
That's my gut feeling as well. And it does fit with what I consider the overall picture, and that is that this is not a volcanic system that's by itself enormously overpressured. It's more like that because of these tectonic events, openings were created and it's oozing out a little.
Yeah,
So, and it's not like a giant explosion or anything. It's more like, of course, a fire fountain is
it's more
spectacular,
like
but
sweating.
it's almost, yeah, it's gentle compared to that. I
Yeah.
mean,
Yeah.
I've seen some
And also
nasty.
in the last eruptions, we've seen that the start of these centric eruptions is not as intense as it used to be in the earlier events, which would fit with that it's an old magma and depleted magma with less gas.
That would make sense that this has been actually degassing. Also, I mean, you hinted at that from the glass chemistry, but I also can see the samples that we collected recently. They're very much evolved. They're full of feldspar, and it seems to get more. And most people probably know, at least, most geologists would know feldspar is a crustal thing. It's not happening in the mantle. So you must be evolving things, and they must be sitting there for some time because feldspar crystals, they need some time to grow as well.
Yeah,
So they're
think
growing at sub millimeters per year, so or maximum that amount. So we're talking about this magma sitting there for a little while, I'm afraid.
it's
So
probably been there for a while, yeah.
I think so. And I mean, if we believe the seismics, what Ari Tryggvason and team were doing, they looked at anomalies, and they had a study in 2002. They published it. There was no anomaly there in that area. But then in 2017, that's when the data show some anomaly of a reservoir. So if this started to get in place after this initial paper in 2002, then we're talking about 20 years or something like this, that some magma could be sitting quite happily down there, and maybe even
or
longer, and we didn't
even
see it,
longer than that.
and we couldn't
Yeah, no,
detect
no,
it exactly.
and it's interesting bring that with how these events sort of I mean, magma accumulation is not clearly in the crust is not a constant thing. It actually is seems to be happening in whether you want to call it episodes or phases or whatever it is, but it's periodic and
Yeah,
it
that makes
happens over a
sense.
certain amount of time, and then it stops. And seismic activity in Snæfellsnes is actually a pretty good indicator of that because you have that bullseye seismicity around Grjótárvatn, in that depth interval of 50 to 20 kilometers. And the only logical explanation for that in reality is that magma is accumulating down there. There's no other seismicity on Snæfellsnes Peninsula.
Okay, that's pretty obvious.
It,
Grant,
it just sits out there on its own.
that's yes, and it's a spectacular place. I remember. Oh my God, when was that? 2008 when you took me there. What a place! So, but anyway, so,
But then again, if you start an event like that, you accumulate magma in the crust. It doesn't necessarily mean that that will become an eruption. It could just stop right there and cool and crystallize. It could result in enough pressurization that the magma will move to shallow level, so you can have a two-level kind of an intrusive event. And then again, it could lead to an eruption eventually. Just
absolutely.
depends on
And
how much you accumulate of the magma and how much excess driving pressure you have in the system.
that's I see that as well, and certainly my experience from other eruptions like the El Hierro eruption in 2011 in the Canaries. The eruption volume was actually rather minor, but the uplift of the island was a lot more. It was something like 20 centimeters of the entire island. If you calculate a layer, a 20 centimeter thickness of rock, if you will, it's a lot more than was erupted. And so we must accept that volcanoes grow internally as
Yeah,
much, if not more, than they grow by eruption. And I think this is something.
and intrusion at that depth might not, result in uh, vertical plus horizontal displacement at the surface that is equal in volume to the magma intrusion because down there, these things may be flowing. The lower part of the crust might actually be moving out.
Absolutely. It could
And
be
so
ductile and
it's that material which is in that critical state where it can behave like a solid sometimes. And if you put some high enough strain on it, then it will flow.
that could
Just
well
like
be.
a butter that you
Absolutely.
take out of the fridge, it stays as a cube on the table if you don't put anything on top of it. But if you put a heavy dish on top of it, it will flatten out.
Which you wouldn't want. But anyway, so
Yes.
yeah. Last point, if you don't mind. Let me just go back to the Met Office, and that is eruption site. Here we have the message, and if we go for the hazard map. Well, maybe there was a better one, but anyway, this is the one now. So the Sundnúkar crater chain is about here, and that is high risk for eruption. So, and according to the Met Office, we really have to expect, if an eruption occurs, we have to expect the same place as before along the Sundnúkar crater row here towards the east of the Svartsengi power plant. Would that be consistent with your estimate of things?
Absolutely. I mean, that's the most likely place. I mean, and it kind of makes sense when you think of it. Well, it's erupted there until now.
Hmm?
And all of these eruptions are using the same pathway to the surface. So they're
Crater.
reoccupying that pathway over and over again. Most
Here's
of
a
the
better map.
eruptions,
So, yeah, it's reusing this area here. Yes.
Yeah, but most of the eruptions, not all of them, with two exceptions, the eruptions have started by Stora Skofeld, just
Yes.
south of it. Yeah, right there. So they start and come up in the same place on a very short fissure to start with, then it starts to lengthen. So just based on that, we would have to consider the most likely possibility for next eruption, if it happens, to be happening in a similar place. But
Of course, we know it doesn't have to be, but there's always
it's just the most likely
exactly.
scenario.
It's a probability kind of issue, and
But one thing that might actually play a role here and may alter things in a way that we might not be able to predict where next eruption starts is that the time now from the last eruption is the longest. So that conduit has had more time to cool now than it actually had before. Not that it is solidified, but if the cooling, the magma that resides in that pathway or conduit, that will get more viscous. It will actually be more ductile than it was before. And we also know that magma in such a state, that's when it's at its strongest.
mm-hmm.
That's a ductile layer, a viscous layer in the lower part of the crust of Páll flows that holds everything up. It's not the brittle part, which doesn't have any strength because it already formed cooling joints in it. So if the core of that pathway is now more viscous than it's been before, and it possibly also strong enough not to let magma come through,
then we could have migration, of course.
then we could either have migration or no eruption at all.
Yeah, sure. I mean, that would certainly, from a civil protection point of view, this would be the most desirable outcome. From a scientific point of view, I'd love to have a concluding eruption just to kind of, wrap it up, because the more eruptions we have, the more we can understand the system and how it evolves. So hopefully no damage is done if it erupts again.
Yeah, but we will also learn if it doesn't erupt, but it also then teaches us something about what we need to think about. And unfortunately, in volcanology, a lot of people ignore this important state that magma can reside in, which is basically its time between the liquidus and the solidus.
Mm-hmm. That is an important thing. And if you had courses on phase diagrams as a student, then you know exactly this is where, the real action
Yeah,
happens. So,
yeah. But also the very important part of that equation is that the rheology of material, of magma between the liquids and the solids, when it is in its ductile state, that's that's what we know the least about. We have very poor understanding of that rheology, but we do know that it's not a linear kind of thing.
mhm.
It does not respond in a linear shape fashion. So clearly, if we really want to understand emplacement of lava flows and be able to model lava flow emplacement more accurately, dike injections, and also how magma chambers expand, we need to understand the rheology of magma in the state between the liquids and the solids.
That's fundamental, and I agree with you. There has been big debate at the La Palma case, for example, about what is the influence of crystals, what's the temperature control, what is the water content, and small changes there can make a huge difference in terms of the rheology.
Yep.
Given the crystallinity, I mentioned the feldspar earlier. I think we must realize that this is becoming more viscous, as you say, and this may have all sorts of consequences.
It may
So
have an impact. Yeah, and crystal shapes might be important in this.
that as well, actually. And of course, once crystals are at a sufficient number, they might touch each other and may
Mm-hmm.
form frameworks because we all know that plagioclase has this wonderful phenomenon that once they meet, they just link to each other, making these glomerocrysts, and because of open bonds at their surfaces. So they find each other and then they become real kind of nuggets in the liquid. And that, of course, makes a huge difference because then it's suspension flow. It's no longer
Yeah.
a liquid, a pure liquid. Okay, great. Let's wrap up.
Material science.
We are moving there, aren't we? So thank you very much, Tor. So let's see how the situation evolves right now while the accumulation rate, just to summarize, is hinting at a possible eruption. On the ground, it seems rather calm, so it may take a little while longer. But given that the accumulation rate is actually dropping, let's see how this all develops. If an eruption comes, it's likely going to be in the same place as before, at least from what we understand now. But possibly there may not be an eruption anymore. So I think this is where we can leave it. And Tor, thank you very much for your time.
Oh, you're
Very
welcome.
much appreciated. Okay,
Until,
all the
until next
best.
time.
Hey, do.
Bye bye.
Bye.